Unreal Engine 5.4 is here, at least preview 1, and it comes with a lot of new cool audio features like audio insights, really cool, also visualizers in the Metasound editor. But it also comes with MIDI for Metasounds. There is a new plugin, the Harmonix plugin, and if you activate that, you get a bunch of notes, and they give you a lot of MIDI features in the Metasound editor. So cool. And also with the Harmonix plugin, you've got a new sample player device, which you can feed a MIDI stream to, and it plays back your MIDI with sample player patches, and this is really cool. But to be honest, the first thing that came to my mind was, we all built like synths with Metasounds, but up till now we always built like mono synths, and now we've got MIDI files, and the MIDI step sequencer both are polyphonic, and why not build a polyphonic Metasound synth? And anyone who has built a synth before knows polyphony is a topic, and I was kind of hoping there is this one new node that takes care of all of that, but I knew it was a long shot, there isn't, but that's not gonna stop us from building a polyphonic synth, right? So let's see what we've got here. First of all, you need to enable that Harmonix plugin, otherwise you won't find the MIDI notes. And once you've done that, then you see there is a new folder, Harmonix, and under the music subfolder you will find all the MIDI notes that we're gonna use. And also on the generators you will find the sample players in mono and stereo. No, where is it? No, not this subfolder of Harmonix. This is the generators here, the Fusion sampler and the Fusion sampler stereo, and these are cool, but we want to build a polyphonic synth. So this here is the section where I'm actually playing the MIDI file. So this is pretty simple. You've got a node which is called MIDI player. It needs a transport input, so MIDI transport input. There's another node trigger to music transport, which gives you basically the functionality to send over transport functions to the MIDI player. And the MIDI player outputs a MIDI stream, and also if you needed a MIDI clock. And we are feeding that to our polyphonic synth here. And we are going to look into how it's built in a sec, but let's first listen to it. Let's tweak some controls here to show that it's actually really the synth playing. Yeah, so I didn't focus on the synth part here because I just wanted to get that whole polyphonic thing going, and so it's really a very, very basic synth, just with an amp envelope, a filter, and a filter envelope, and you can choose a basic waveform here. So if you play back the same thing with a square wave, it sounds like this. But the cool thing is it plays back my MIDI file polyphonically. So this is what I was experimenting with, and that's what we're going to take a look at. So what we need to do is to separate the MIDI notes from the MIDI stream here. And I went through all the notes that come with a new Harmonix plugin, and found a note trigger, MIDI Note Trigger note here. I thought, okay, this looks promising, because it will obviously report every note on and every note off that's happening in the MIDI stream with the corresponding MIDI note number and the velocity value. So that's cool. That's pretty much exactly what we need here. But then I got curious, and I was thinking, what's gonna happen if two or more MIDI notes are happening exactly at the same timing position? When 2 or 3 or 4 MIDI notes have the exact same timestamp on them. And this is something that wouldn't be a problem in the original MIDI protocol, because the original MIDI protocol is a serial protocol, which means that nothing is happening exactly at the same time. Even if you have 3 MIDI notes that are being played exactly at the same time, they will be transmitted one after the other pretty quickly, one after the other, because the original MIDI protocol could send about 1,000 MIDI commands per second. So this would be close enough for rock and roll, but still it's not happening exactly at the same time. And I was wondering if the same thing is happening here. So what I did is I created a MIDI file with exactly this situation. 3 voice chords, meaning that I've got 2 chords playing and both of them are hard quantized. So the note ons are happening exactly at the same timing position. And the easiest way to check this is to use a print string for integers, and we're gonna label that with note number, and the value to log will be the note number. And let's see what's going to happen here if I'm pressing play now. Okay, we can see it in a second. But as you can already see, there is a bit of a problem here. You're hearing that there are 3 notes with every chord, but the print string only reports 2 different notes here. So that means when 3 or more notes are played exactly at the same time, this note here will only report one of them and will skip the other 2. So that's a bit of a problem here, because we need the information for all of the notes. And so we have to come up with another solution. So obviously our problem is that a single trigger output can transmit only one single trigger event at a specific sample position, which is quite logical if you come to think about it. But it's a problem for us. So what we need to do is to come up with a solution where we can kind of dissect the MIDI stream and separate the MIDI stream into separate note on and note off trigger outputs, preferably one for each and every note, which is quite a lot, but this is exactly what I did. So let's get rid of this. And I made a Metasound patch for that, and it looks pretty much like this. And I found another node which is quite helpful for our problem, because it's the MIDI note filter node. And what it does is you can feed it a MIDI stream and then filter a range of MIDI notes, or you can also filter by velocity range. But I used it to filter one MIDI note out of the MIDI stream by plugging in the same note number for minimum and maximum note, and leaving the velocity the default values. The MIDI stream that is being fed into the next note here is just the MIDI stream of a single note. And for a single note, I can be sure that there are not 2 events happening at exactly the same time. So I didn't want my Metasound patch to become too large, so I did this for 1 octave here, and it works like I've got an octave input here, and there's a little calculation, and obviously note number 60 will be my bass octave, which means note number 60 is the middle C on the keyboard. Musicians call it C1. In MIDI terms, it's called C3. Anyways, it's note number 60. So if the octave value is 0, then you get exactly the notes for 1 octave starting at MIDI note 60. And if you get octave plus 1, then it's the next octave above that. And if you get octave minus 1, it's the octave below that, and so on and so forth. So this is for 1 octave, and I'm filtering the one single note here, MIDI note number 60 for the first note filter, 61 for the next note filter, and so on. And I'm feeding these to the Metasound patch outputs. As you see here, I'm separating note on, note off, note number, and velocity for each single note here. And this is how I'm separating the MIDI notes, octave per octave. And this is how this Metasound patch looks when you're using it in another Metasound patch. So you've got separate trigger outputs for each and every note number in that 1 octave. For a C, you've got a note on, note off, the note number, the velocity, C sharp, the same thing, on, off, note number, velocity, and so on, all the way through the last note here. And I was thinking about implementing a voice restriction like in the old analog synths where you had a 4-voice polyphony or a 6-voice, 8-voice polyphony, whatever. But eventually that would bring us in a situation where we had to combine trigger events again, and they might happen at the exact same time, and then we would run into the exact same troubles that we are trying to avoid here. So I decided to use a separate oscillator for each and every note number here. And this is a lot, I know. But what we can do is that we are disabling the oscillators by default and only enabling them when we actually need them. So when a note on event is coming to the oscillator, we're going to enable them. And then once the sound has finished with the release phase, then we could disable the oscillator again. And that is what I did. And this actually saves a lot of CPU power. So how I'm cabling this, and you see there's a lot of cabling going on, is that I'm connecting each note to its own voice, when the one voice is just a little simple mono synth, and I'm controlling all of the synths with the same inputs here. And let's have a look at one instance of a mono synth. Looks like this, and this is the oscillator. I'm using the super oscillator here, and this is the actually very easy logic that enables and disables the oscillator. So I'm using my envelope, which we need anyway. An amp envelope is always there in a synth. So when the attack is triggered, which happens when the note on is coming in, then we set a boolean to true, the target value to true, and feeding that into the enabled slot here. And when we're done with the envelope, so when the release time has finished, then we are resetting the Boolean value to false and disable the oscillator here. So this is pretty easy, but it saves a lot of CPU power, and this is really cool. If I could do the same thing with the filters, that would be great. If there was a bypass option, then I could also save a lot of CPU power with the filters. But all in all, it's quite okay on the CPU, the way it's working. Let's have a look what else there is in the synth. But it's just really a basic synth. I'm really not focusing on the synth part. I just wanted to get the polyphony to work. And so I'm using this oscillator here, obviously, and a filter, then the envelopes, one envelope for the amp envelope, of course, and another envelope for the filtering, the mapping for the filter envelope amount. And what else have we got? Of course, the velocity thing here. Maybe that's interesting as well. You have to think of the fact that a note off event also has its own velocity value, which is called the note off velocity. And most keyboards cannot measure their note off velocity separately, and they're just putting out 64 or any kind of fantasy value. But there is a value because that's part of the MIDI protocol, that a note off event actually needs a velocity value. And I only want to use the velocity values for the note on events. So that's why I'm inserting this value node here that is triggered by the node on event, and only setting the velocity value for the node on events and ignoring the node off velocity values. Because if you don't do that, then you get sudden volume changes every time you're releasing a note and you don't know why that's happening. That's because of the node off velocity. So that's what's happening here. And other than that, the only thing is a logic for the sustain pedal, but we're going to look at this logic a little bit later. And let us just quickly have a look how I'm putting the octaves together. Again, all my inputs, my controls here are going to all instances of my synths, of every voice of the synth, and this is just stacking up all the octaves. So I'm starting with octave 0 here, which is the middle C, and then this one is 1 octave below, and then going 2 octaves below, 3 octaves below, and the same in the other directions until we get to octave number 3. And then mixing everything together. and this is also Metasound patch, and everything is combined by this patch here, where we've got the MIDI file player. Then this is the synth where all the octaves are being stacked together, with my controls for the amp envelope, the filter envelope, and a little bit of a velocity compression. Adding just a little slap echo to make it a little bit more stereo. And yeah, well, the last thing that we need to talk about is the sustain pedal. So a sustain pedal also affects the note off behavior of MIDI notes. Essentially, when you are pressing a sustain pedal, it should prevent note off events for all of the notes. But when you let go of the sustain pedal, you cannot just simply send note off events to all of the notes, because you might still be holding some of the notes on your keyboard, and these notes should not be cut off at that moment. So the sustain pedal needs to remember for which notes it has prevented note off events. And when you release the sustain pedal, note off events should only be sent to those note numbers where you have prevented note off events while the sustain pedal was pressed. So let's just have a look at it. And there is this one note which is called MIDI CC trigger, which just reports values of specific control changes. And the sustain pedal always uses control number 64. With values below 64, the sustain pedal is off, and above 64 to 127, the sustain pedal is on. So the kind of information that we need for this is provided by this note, which is cool. We can just use this. And in our synth, the logic goes like this. So first of all, we want to know if the sustain pedal is currently pressed or not, and store that in a Boolean variable, which is happening here. So the control change values for 64, the sustain pedal, are coming in right here. And every time the value is changing here, so the pedal is released or pressed, then we want to do something. So we need a trigger on value change node here. And I'm delaying the trigger just by a tiny bit in order to prevent that note off events and the release of the sustain pedal are happening exactly at the same time. Because if you have a manual recording as a MIDI file, that won't happen anyway. But if you have something that is programmed in a DAW, then sometimes it happens that note offs and sustain pedal release events are happening exactly at the same time. And this is just for preventing these kind of situations, and just make sure that we're not running into any problems here. So we know above 63, 64 up to 127 means the sustain pedal is on, and below means the sustain pedal is off. So we're doing a trigger compare here, and if the result is true, so if the sustain pedal is on, then we're using again a value node here to set this Boolean variable to the target value true. And if it's false, so if the sustain pedal is being released, we're resetting it to false. So we always know if the sustain pedal is on or off at the moment. Okay, that's the first part. When a note off event is happening, this is what's going on down here. When a note off event is happening, we want to know if the sustain pedal is on. And if this is the case, we want to ignore the note off, but also we want to store that information that we have just prevented a note off event to happen. If we want a note off, we need to trigger the releases of the envelope. So this is happening here. So if the note off should actually take place, it needs to get up here. But we need to take into account if the sustain pedal is on or off. So a note off event is coming in right here. And the first thing we do is we check if the sustain pedal is on or off, which happens here. And if it's on, it's going to trigger out 1. If it's off, it's going to trigger out 0, which is exactly what we want. Because if the sustain pedal is off, then we, of course, want the note off to happen. And it just is going up here, trigger any, passes through, and triggers the releases of the envelopes. If the note off is happening while the sustain pedal is on, it should be ignored for the moment, but we need to store that information. So it goes down here, and we're setting that Boolean variable, which I called sustain pedal just prevented note off, which sets this Boolean variable to true, because we're setting it here, and setting means it triggers the target value, which is true. And so we know, and we have saved that this just happened. Okay, what happens if a sustain pedal is released? Well, if we haven't just prevented a note off message because of the sustain pedal, nothing should happen, because that means either we're still holding the notes on the keyboard or the whole oscillator is inactive altogether. So nothing should happen in both cases. But if we just have prevented a note off command because of the sustain pedal, we need to make up for that now that the sustain pedal is released. And now is the moment to send out that trigger release message. Okay, let's take a look how we actually do this. So when the sustain pedal is released, then we're getting an information or a trigger from the false output here. And it goes to this trigger select, and this trigger select is controlled by this boolean that we just stored here. And we are using a delayed get. We cannot use it in the same cycle of calculations. So on the next block, we're getting that information, but that's okay. That's actually the way it works. And so my trigger select here will output 1 on the trigger 1 if we just prevented the note off, and that's the situation where we actually want to send out the trigger release to the envelopes. And if that's not the case, it just goes into nothing and nothing happens, which is exactly what we want. And that is the whole logic. There's nothing more to it. So I hope this was useful for some of you. I think it's really great that we have MIDI in Metasounds now, and we're going to do so many great things with that in the future. I'd also be glad if you check out my Sonic Liveforms app. There will be video pop-ups somewhere here, and let's listen to another polyphonic MIDI file.